Hey everyone, this is Mr. Skelton. We are back at it again, lesson 10, unit 3. Today we're doing the quadratic formula. Our learning target check is to use the quadratic formula to solve quadratic equations. The nice thing about the quadratic formula, it can be used to solve any quadratic. Okay? So when we were talking earlier about, when you look at specific quadratic expressions, some lend themselves to better ways of solving them. We talked about factoring. We've talked about square rooting. We've talked about completing the square. Kind of shorthanding this stuff here. We've talked about graphing. And now we got a fifth one, which is the quad formula. Okay? And really, when you look at these 5 methods, this should be square rooting. This method here, square rooting, remember, if it just has x squared only, then you want to look to solve by square rooting. Completing the square we talked about, if your b value is even, right? 2, 4, 6, or 8 if your b value, because then you won't have fractions. Factoring, you just kind of have to recognize, and sometimes that's tough, but sometimes you can recognize if it's factorable. With graphing, it's really any, right? Because you can plug that into your graphing calculator. And with quadratic formula, it's any. What I mean by any, it's any quadratic will work graphing or quadratic formula. Just a couple of the other ones you may have to recognize which method is best. So a lot of you know the quadratic formula already. You learned this in Algebra 1. It's negative b plus or minus the square root of b squared minus 4ac. And that whole thing is all over 2 times a. Now when we talk about the quadratic formula, these letters right here, B, B, A, or A, C, and A, those all come from your A value, your B value, and your C value of a standard form quadratic equation. Now, this is the quadratic formula. You should know this. Most of you don't know where this comes from, so what I'm going to do first is I'm going to kind of show you where the quadratic formula comes from using standard form. So I'm going to show you how to get the quadratic formula by completing the square. Well, what's the first rule of completing the square? We want to get and divide out our a values on everything. So what we get is x squared plus b over ax plus c over a, and that equals 0, right? 0 divided by anything is going to be 0. And then we want to complete the square. So I have x squared plus b over ax, leave a space. I'm going to subtract the c over a to the other side, and I'm going to leave a space. So we take half of our b value, so it's b over a. I'm going to divide that by 2, right? And then I have a fraction within a fraction, so I'm going to multiply by the reciprocal, so I end up getting b over 2a, and then I'm going to square that. b times 1 is b, a times 2 is 2a, so half of b is b over 2a, but I'm going to square that, so I'm going to add b squared over 4a squared. Now you may be wondering how I got 4a squared. Remember, when you square a fraction, you square the top and the bottom. 2a squared is 4a squared, so I need to add b squared over 4a squared there. Now, right here, the whole point of completing the square is to get a perfect square trinomial. So I can rewrite that as x plus b over 2a squared equaling. Now, over here, I got to get a common denominator. So I have 4a squared and I have a. So if I times, use a different color here, if I times this by 4a and 4a, what I'm going to get then is a negative 4ac over 4a squared plus b squared over 4a squared. I know this is getting a little messy, but bear with me here. Now I'm going to rewrite this side with a common denominator, so I get x plus b over 2a squared equals. When we express this, we want it in standard form, which means our largest exponent goes first. So I'm actually going to switch this around. It's going to be b squared minus 4ac all over 4a squared. And then how do I solve? I solve by square rooting and square rooting. So I'm left with x plus b over 2a equals. Now, remember, when you square root, you're technically square rooting the top and the bottom, so it's going to be plus or minus, because I did the square rooting, the square root of b squared minus 4ac. Now, the bottom, these are perfect squares. 4 is a perfect square. Square root of 4 is 2. Square root of a squared is just a. So there's that, okay? And then I just subtract b over 2a. I know I'm running out of space here, but this is how it's going to look. X equals, I'm going to write this part in front of my plus or minus, right? That's how we usually write it. So it's negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And since these have a common denominator, I can write it as x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And that is how you derive the quadratic formula from standard form using completing the square. Pretty neat, huh? All right, so long story short, we're using the quadratic formula. So here we go. And again, just for a reminder, ax squared plus bx plus c, that's called standard form. You should know that by now. That's standard form. And your a, b, and c, whatever those values are, that's what gets substituted in for this b, a, c, and a. All right, so let's take a look at some problems and try some of these. So it says, let's solve the following quadratics. Again, I would look at these and go through my 5 methods. Can I solve this by factoring? Can I solve this by square rooting? You know, what method lends itself? Should I complete the square here? Probably not. Looks messy. So quadratic formula. I always write down what my a, b, and c values are so that when I go to plug them in, I'm not making any mistakes. And so I have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's write these in. I should use my blue pen here. So I'm going to get equals negative 6 plus or minus 6 squared is 36 minus 4 times 5 times a negative 2. And that's all over 2 times 5. So let's simplify. Negative 6 plus or minus square root of 36. Let's see, that's going to give me negative, this is a negative 4. Negative 4 times 5 is negative 20. Negative 20 times negative 2 is positive 40. All over 10. So I get negative 6 plus or minus the square root of 76 all over 10. And let me just see if I can simplify 76. 76 divided by 4 is 19. All right, so I can break down 76. So I get negative 6 plus or minus 2 square root 19 all over 10. And that's what x equals, and that is my answer. Okay, now you can write it as 2 separate. You could go negative 6 plus 2 radical 19 over 10. And x equals negative 6 minus 2 radical 19 over 10. You could write both of your answers like that if you would like to as well. But it's the same thing. Okay? Now I'm going to point out something here in all of these problems. When I got a positive number 76. I know that's not going to make sense to you right now. I mean, I know you know how to get 76, but I'm going to explain the importance of getting a positive number underneath the square root. I'm just going to write here, I'm just going to write positive. That's going to yield something towards the end of this lesson. Okay, this one here, again, when we talk about methods, I look at this and I say, wait a minute, I'm solving, so I can divide everything by 4. I see a GCF, right? So I get x squared plus 2x plus 1. Now, is this factorable? That's what I'd be asking myself. Can I factor this? Are there two numbers that multiply together that give you 1? Add together, you get 2. Well, what does that give you? 1 times 1 is 1. 1 plus 1 is 2. But we could solve this for factoring, but I wanted to show you that so you could see that you could factor, but I'm going to solve with the quadratic formula since that's what we're practicing. Okay? So my a value is a 1, my b value is a 2, my c value is a 1. X equals negative 2, which is my b, plus or minus the square root of b squared, which is 4, minus 4 times a times c, all over 2 times 1. So I get x equals negative 2 plus or minus 4 times 1 is 4, so I get the square root of 0. What's the square root of 0? It's just 0, so I get x equals negative 2 plus or minus 0 all over 2. Well, plus or minus 0 doesn't mean anything, so I get x equals negative 2 over 2, which is just x equals negative 1. Okay? Now, again, I want to point out something. I got a 0 underneath my square root symbol. I'm going to come back to that in a second. And I also want to go back to the original problem and show you using the quadratic formula is possible, but you could go x plus 1 times x plus 1, right? 1 times 1 equals 1. 1 plus 1 is 2. Set that equal to 0. I get x plus 1 equals 0. X plus 1 equals 0. X equals negative 1. X equals negative 1. So you can see that the answer is just negative 1, which I have there. Again, recognizing what method is best is important. I showed you the quadratic formula, but again, you could solve that one faster by factoring. Okay, let's see. Am I missing something here? I don't think I am. Nope. Here we go. So it says, what about this one? So let's try number 3, and then we'll talk about the discriminant here in a second. So again, I'm going to write down my A value is negative 2, my B value is 3, my C value is negative 5, okay? And again, I can't factor anything out like I did before, so I just go right into it. So it's x equals negative B plus or minus the square root of B squared, which is 9 minus 4, times negative 2 times C, which is negative 5, all over 2 times negative 2. Let's simplify. Negative 3 plus or minus the square root of, that's going to be 9. Negative 4 times negative 2 is positive 8. Positive 8 times negative 5 is negative 40. All over negative 4, so I get negative 3 plus or minus the square root of negative 31. All over negative 4, 31. Look what I was doing. Negative 31. Now, we just learned a couple lessons ago about square roots underneath, or negatives underneath the square root. So this becomes, I should probably put x equals here so you can follow along, going right down. X equals negative 3 plus or minus. Now I can't break down 31, but I do know that that is square root of negative 1 times 31, which is I. So I'm going to get I radical 31 all over negative 4. And that would be my answer there. Now again, you can write this as negative 3 plus I square root 31 over negative 4, and negative 3 minus I radical 31 all over negative 4. Either one of those answers would suffice. Okay, I'm also going to take my highlighter back out and show you that I got a negative, okay, underneath my square root. The reason I highlighted the number or the sum under whatever I got underneath the square root symbol is important. That's called the discriminant. The discriminant is the b squared minus 4ac, which is this part underneath the square root, which yields this number. If you go back to 2 and 3, or 1 and 2, you'll notice the discriminant is b squared minus 4ac, which is this part right here. But when you simplify that, you got 76, which is a positive number. On this one here, here's your b squared minus 4ac. We got 0 underneath the square root symbol. All right? 76 is the discriminant. 0 is the discriminant. On number 3, negative 31 is what we call the discriminant. It's when you simplify all that together. That's what the discriminant is. And what does it tell you? It tells you how many solutions you're going to have. Okay? The discriminant tells you how many solutions. If your discriminant gives you, here's what you need to know. If your discriminant is positive, so like on number 1, we got 76. How many solutions did we get? We got 2 real solutions. Notice there's no I in here. Okay? We got 2 real solutions. So you get 2 real solutions if your discriminant is positive. Okay? That's the b squared minus 4ac. If you work all that out and you get a positive number, you're going to get 2 real solutions. 2 imaginary solutions is when your discriminant is negative. So when your b squared minus 4ac is a negative number, you're going to get 2 imaginary solutions. Look, right, because I comes out, here's where I broke it into 2 solutions. You have negative 3 plus I radical 31 over negative 4, and negative 3 minus I radical 31 over negative 4. That's 2 different solutions, and they're both imaginary. They both have I. You get 1 solution if your discriminant is a 0. That means if you get b squared minus 4ac, and you simplify all this out, and you get the square root of 0, just like on this one right here, how many solutions did we get? We just got x equals negative 1. Okay? So that's what the discriminant can help you. So again, I can give you a problem on a quiz or a test and say, find the discriminant, tell me how many solutions you would have, and that would just be doing the b squared minus 4ac part, and whatever you get, you get. Okay? All right, if you have any questions, we'll see you in class.